All right, solving systems of equations by elimination part 2. Now, the only difference today is going to be the equations won't be completely set up for you. So remember, when we looked at equations yesterday, we had things like this. 4x minus 7y equals 27. Negative 2x plus 7y equals negative 17. And the key thing that we noticed was that either x or y had two coefficients that were additive inverses. They were the same number, but opposite signs. The whole reason that this was important was when we add this equation together with this equation, negative 7y plus 7y is going to drop out. So 4x minus 2x, that's going to be 2x. This is going to drop out, so I have no more y, and this would equal 10 in this equation. I now have one equation with one variable, which is something that we can solve. But if this had not been a negative and a positive, I would have still had two variables, and I wouldn't have been able to solve that. Right, so now I could solve this. Let's finish this one up. X equals 5, because we divide both sides by 2. And if x equals 5, we plug that in here. We have 4 times 5 minus 7y equals 27. Or 20 minus 7y equals 27. Subtracting 20 from both sides, we get negative 7y equals 7. Dividing by negative 7, we get y equals negative 1. So the answer to this problem would be 5 comma negative 1. Maybe in a second, but we're going to learn something a little bit different. So let's say, I'm going to actually use the same problem. Let's say I gave you a problem like this. Actually, let's use a different one. I think it would be too confusing to use. Let's say I gave you something like this. X plus y equals 0. And then negative x plus y. Actually, this one. Sorry. Bad example. Okay, let's try this one. 2x plus 5y equals 12. And negative 4x plus 5y equals 6. Okay. So let's look at this example now. We have an x and a y. We have two equations. So we have a system of equations. I'm going to look for substitution, but I don't see an x equals or a y equals. So substitution is not a very good way to solve this, probably. Next thing I'm going to look for is elimination. If I add these together, I'm going to get a negative 2x. If I add these together, I'm going to get 10y. So I can't just add those two equations together as they stand. But I can actually change each equation. Remember that golden rule of algebra. I can change any equation I want as long as I do the same thing to both sides of the equation. So in this example, I'm going to need to make this negative so that it cancels out with this. To make this negative, I have to multiply times negative 1. But remember, I have to multiply the whole side of the equation times negative 1. And then I have to multiply this side of the equation times negative.
Wait, why would you multiply by negative 1?
Because when I multiply by negative 1, this is going to turn into negative 5y.
And do you do that all the time?
That will give me a new equation that I can add to here and eliminate.
Do you do that all the time? Is it required?
Well, let me show you. So if you didn't do this, let's go back a step. Let's say I didn't do this. And I said, okay, I'm going to add these equations together. I would get 2x minus 4x, that's negative 2x. 5y plus 5y, that's 10y. And 12 plus 6, that's 18. Can you solve this?
Yeah.
No.
Wait, no.
It has two variables.
What good is
You
that?
can never solve an equation with two variables,
It was a graph,
x
yeah.
and y. You could graph this as a line, but that's not what we're trying to do. We're trying to find the point where these two lines intersect. One point. Right? So this is not going to help me to solve this system of equations. This is not going to do anything for me because I still have two variables. So I'm noticing that this is a 5 and this is a 5. If this were just a negative 5, those would cancel out. Those would cancel each other out. So I'm multiplying by negative 1 to make this a negative 5. And I multiply the other side times negative 1 so that I still am not changing the equation. I'm keeping it the same, I'm just multiplying both sides by negative 1. So let's do this. Multiplying by negative 1 is pretty easy. All we have to do is change every sign. So negative 4x becomes positive 4x. Positive 5y becomes negative 5y. And a positive 6 becomes a negative 6. Okay, so I've eliminated this equation. I've changed it into this equation. I'm now going to just rewrite this equation down here just to make it easy to see. And now, I notice, just like I wanted, I have a minus 5y and a plus 5y that will cancel each other out. I will no longer have a y when I add these two equations together. So I'm going to add them together. 4x and 2x is 6x. Negative 5y and positive 5y, that's 0. Negative 6 and positive 12 is a positive 6. Now I have an equation that can be solved. One variable, just an x. So I divide both sides by 6, and I find that x equals 1. Okay, now I found x equals, I can go back and plug this in up here to find what y equals. So let's say I had 2, I'm going to plug it into this equation. 2 times x, which is 1, plus 5y equals 12. Again, this is now a one equation with one variable which I can solve. So 2 times 1 is 2, plus 5y equals 12. Subtract 2 from both sides to get the y term alone. We have 5y equals 10. Divide both sides by 5, and we have y equals 2. So x equals 1, y equals 2. I'm going to write my final equation as, my final solution as an ordered pair over here. 1 comma 2. It's usually worth it to check your work. So I would take this original equation that they gave me, negative 4x, so negative 4x, and I think x is 1, plus 5y, and I think y is 2, equals 6. And let's see if this works. Negative 4 plus 10 equals 6. That is true. 6 does equal 6. So this answer checks out as being true. In that second equation. Yeah. Do you have a question?
Oh, I said that.
Oh, you got it?
Yeah.
You suddenly understood? A moment of epiphany. Aren't those awesome? Okay. This is it. This is all we're going to do for now. There is another step to this, but we'll talk about the other step tomorrow. Okay? So it's the same thing as last night's homework. You're just multiplying one equation by negative 1 first.